Hello again, everyone. This is the last part of proving geometric properties using coordinate proof. So let's go directly to the questions or to the problem that needs proving. Prove that the perpendicular bisector of the base of an isosceles triangle passes through its vertex. So we're now looking for a perpendicular bisector of a triangle. So let's write an isosceles triangle. So this will be an isosceles triangle. So this one is a proof that this is an isosceles triangle. We get the distance of AC and the distance of BC. So by doing that, to do that we use the distance formula. We just substitute the points that of our given. So A minus 0, that is x sub 2 minus x sub 1, and B minus 0, and that gives us this answer. On the other hand, we have A minus 2A, that gives us negative a squared, that is a squared, and b minus 0, that is b squared. So they have the same distance, so this is an isosceles triangle. Now to prove that the perpendicular bisector of this triangle, we need to get the midpoint of its base, that is 0 comma 0 and 2a comma 0. So we can just easily get the midpoint of this by adding x coordinate of both point and divide it into 2. So that gives us a comma 0, because 0 plus 2a is equal to 2a divided by 2 is equals to a. So that's how we get that. So we name that point D. Now, perpendicular bisector is a line that bisect a perpendicular line that bisect a line segment. So it's since the midpoint of the bases and the vertex of a triangle lies on the same ordinates, so that is a coordinates. Sorry, that this should be coordinates. Then the perpendicular bisector of an isosceles line passes through its vertex. So this is one of the proof. So we can prove it further by getting the slope of this line and the slope of this line, and if we compare them to each other, it will give us a value of -1. But that would be impossible because this will give us a slope of 0 and this will give us a slope of undefined. This will be an undefined slope and this will be a 0 slope. We could do that if we rearrange the triangle into another placement in the Cartesian plane. For number 2, prove that if the diagonals of a parallelogram are congruent, then it is a triangle. So let's place a parallelogram first. No, it doesn't matter what kind of a parallelogram, but as you can see, this is a rectangle. So I put on the coordinates of the vertices. Now we will prove that the diagonals of parallelogram are congruent. So this is a rectangle. So all we need to do is to prove that this line are congruent so that we could prove that this is a rectangle. So using the distance formula, we get the distance of AD and BC, and that gives us the same value. So since AD and BC are equal to each other, then the diagonals of a rectangle are equal. So therefore, this is a rectangle. The midsegment of an isosceles triangle form another isosceles triangle. So let's use this. So this is an isosceles triangle. We already Let's get the midpoint of all of the sides of this one. So this one is 2a plus 0 divided by 2, that is a. 2b plus 0 divided by 2, that is b. So that is the midpoint of that. On the other hand, let's do this. 2a plus 4a, that is 6a divided by 2, that is 3a. 2b plus 0, that is 2b divided by 2, that is b. So let's use the formula for clarification. Okay, so that's it. Okay, let's see if the triangle form is another isosceles triangle? Okay, since DC is equal to EC, then the mid segment of an isosceles triangle form another isosceles triangle. So this is a kind of indifferent proof. So I think I we forgot to get the coordinates of this. So if the coordinate of this should be 2a comma 0, because 0 plus 4a is equals to 4a divided by 2, that is 2a. Now if we're going to connect this one and connect this one, we'll be creating another triangle. Now let's prove that this is another isosceles triangle. We know that the measure of this is 2a. 2a, that is the measurement of this one. So that is DE. Now let's get the measurement of D. Let's name this F, DF. So I will be, okay, so let's find the distance of DF. So DF is equivalent to 2A minus A squared plus 0 minus B squared. That gives us A squared plus B squared. So that is DF. So let's get EF. So that gives us 3A minus 2A squared plus B minus 0 squared. That gives us A squared plus B squared. So since DF and EF are congruent and DE is 2A, therefore we could we could conclude that the triangle formed by joining the mid-segment of an isosceles triangle form another isosceles triangle. Okay, so I'm sorry I made some mistake here, or I made some wrong assumption here. I thought that this is the triangle that is referring to, but we already solved another one. For this part, prove that the segment joining the midpoint of the opposite sides of quadrilateral bisect each other. Okay, let's prove that so this is a quadrilateral. Any quadrilateral will do. I choose rectangle here and I write these coordinates. Now let's prove that the mid segment joining the midpoints are of the opposite side bisect each other. So let's get the midpoint of all of this. So that's how we get the midpoints. Okay. So now with these midpoints, let's join this. Let's get the midpoint of each mid segment. Okay. Since they have the same midpoint, therefore we can say that they bisect each other. So that's how we prove this. For our last problem, prove analytically that the line segment joining the midpoint of two sides of a triangle are parallel to the third side. So let's get a triangle. So let's get the midpoint of AC, and let's get the midpoint of BC. So that's the midpoint. So let's prove analytically that joining the midpoint of the triangle. So let's get the slope of DE, that is 0, and the midpoint also, and the slope also of AB, that is 0. Since these two lines are equal, have equal slope, then therefore the mid segment of a triangle this is triangle is parallel to the base, to the base. Okay, So that's it. So I hope there are some mistakes in the presentation that I hope that you could understand that. So please stay tuned for the circle equation for the next video tutorial. So that's it. Bye bye.